we're going to do objective 17. We are going to solve quadratics by completing the square. Okay, so give it a chance. Before we're going to start out little, I want to make sure that you can do the process of completing the square with smaller numbers before we get into imaginaries, before we get into non-perfect radicals and things of that nature, before we get into fractions and other things like that. Okay, so the first couple examples, you're going to be looking at me going, well, I just do this one by factoring. Well, yeah, I agree. I do this one by factoring too, but I want you to get the process of how to complete the square before I give you something that's a little more difficult. Okay? Any questions so far? All right. So our goal today is that we are going to make perfect square trinomials. Okay? When I square a binomial, and you don't need to write this part down, give me a binomial that I would square. X plus 3 squared, right? If I square something, that means I'm going to times it by itself, correct? And so if I FOIL this out, what would I have? X squared, which would be, so the whole thing would be 6x plus 9. This is a perfect square trinomial. I want you to understand that. That is a perfect square trinomial because when you take the square root of it, you get two binomials that are being, this is the same binomial times the same binomial that's squared, okay, multiplied by itself, okay? So what we're going to do is we're going to complete the square or make this up here into a perfect square trinomial. So I can tell you right now, as is, it is not a perfect square trinomial. So what we're going to do is we're going to make it a perfect square trinomial. And we're going to take this part right here and we're going to throw it over to the other side. And I'm going to add something on this side. And we know if we add something to one side, we must add something to the other side. Do you understand that? If you have an equation that's balanced, if I add a certain amount to this side, in order to keep it balanced, I've got to add it to the other side. So what we're going to do is we're going to finish out this trinomial into what would be a perfect square trinomial. Here's the key. You take half of the middle number, what's half of 10? And square it. 25. We now have a perfect square trinomial, and I will show you how it is a perfect square trinomial in a minute. If I add 25 to this side, then I've got to add 25 to that side. At this point in time, we're going to factor it. Now, I'm going to factor it on this very first one, but after I do the first one, we're going to be able to skip this middle step, and they'll start going quicker. So, if I factored this, what would it be? X and X and plus 5 and plus 5. Does everybody see that that is a perfect square trinomial? Because when you factor it, you get two binomials that are the same, okay, which would be squaring it. What's another way to write x plus 5 squared? Or, I just told you. X plus 5 times x plus 5 would be x plus 5 squared. Okay, that's another way to write that. So, what we need to do is we need to solve for x. So in order to get that x by itself first, we've got to get rid of that square. What's the opposite of squaring? Taking the square root. The opposite of squaring is taking the square root. So if I take the square root on this side, what do I know about the other side? I've got to take the square root on the other side. Now, what do we know about square and square root? They're the opposite. So what will happen? If this is my jam. You ready? Cancel. Okay, they're going to cancel out. What does it leave you? It leaves you with x plus 5. What's the square root of 36? I give up. I'm just kidding. Okay, what's the square root of 36? Plus or minus 6. And then from there, we just solve for x. We're going to move this 5 over, and this will make negative 5 plus or minus 6. And you can actually, can you continue on with this one? and actually find your two answers? Sure. Negative 5 plus 6 would be 1. So that's one answer. And negative 5 it'll work. And negative 5 minus 6 would be negative 11. And those would be your two answers. Now look at did anybody look at the original problem and say this one was factorable? And what are the factors? If you look at the original problem, what are the factors? If I factored that, that would be x plus 11 and x minus 1. But if the factors are 11 and negative 1, what are the actual answers or solutions or zeros? 1 and negative 11. Okay, and that makes sense to us. Okay, now I will tell you this. I've only done one. So don't judge yet. Some of you are already going, I like yesterday's way better. Okay, I've only done one. Stay with me. How many did I lose on that one example? How many kind of, sort of, maybe followed with me? Okay, how many you can already tell you're going to really like this? Okay, so just don't judge yet. Let me keep rolling. So, example 2. I will tell you this. Before, normally we set everything equal to 0, and you're going to have to set everything equal to 0. But before you start setting it equal to 0, look at it and see, the goal here is to complete the square. Okay? What did I tell you that the magic number would be? How do you get that? You take the middle number and you do what with it? Take half of it, which would be what? 6, and then square it. So do I already have a perfect square trinomial? So I don't need to set it equal to 0 and move this over here because you're going to be like backtracking steps. So you've already got it set up to where it's a perfect square trinomial. So from here, let's just factor it. Now, I did tell you we'd be able to cut the factoring out of it a little bit if you understand. We need to factor it into something times something. It would be x, and what times what? Negative 6. Does everybody agree? Negative 6 times negative 6 would be positive 36, but when you add the outer and the inner, you would get negative 12. Okay, now the key is, how do you get this number? Like, what if it's not that obvious? You just take half of your middle number. That's what number goes right there. It's just the half before you square it. Or you could do what with it? Take the square root of that. Does that make sense? It's the number you get before you square it. So from there, what do I do to solve it? How do I get rid of the square? We're going to take the square root on both sides. What happens to the square and the square root? Cancel. And you get x minus 6. What's the square root of 25? Plus or minus 5. And then we're going to just solve. So x is equal to 6 plus or minus 5. 6 plus 5 would be 11, and 6 minus 5 would be 1. And those would be your two answers. Any questions? Yes. Okay, so the question is, can you leave it x equals 6 plus or minus 5? So if it's plus or minus 5i, I would leave it because you can't add the imaginaries with it. If it's x equals 6 plus or minus the square root of 5, I would leave it because it's a radical. You can't add the 6 with a radical. But because you can add a 6 with a 5, I would keep rolling. Does that make sense? So if it's like two whole numbers or two integers, I would keep rolling with it and add them together. But if it's like a radical or if it's got an imaginary or something that's different, leave it. Okay? Yeah, you would say, okay, my answers are 11 and 1. Like so. Okay? So is this one that is factorable? Is this one that is factorable? Yes? What's the factors? x minus 6 and x minus 4. So what's the actual answers? 6 and 4. Okay, so we know we're working towards 6 and 4, and I agree. On the test on Thursday, if it looks like this, by golly, I would just say 6 and 4 and click the answer and be done with it, okay? But because we're completing the square today, let's use the method of completing the square, because there are times when things aren't factorable, right? There are times when things you can't put in the calculator, so you're going to have to know how to complete the square. So my question is this one a perfect square trinomial? What needs to be at the end? 25. How do you get that magic number at the end? You take half of 10, which is, and then square it and get 25. So what do we need to do with this 24? Throw it away, okay? We need to move him over and replace it with something that will be a perfect trinomial. And I do agree 25 is the magic number, okay? 25. And if I add 25 on this side, then I need to add 25 on that side. So far, so good. Because you got to find something that will complete the perfect trinomial. And so to get this number, you take half of this middle number, half of 10 is, and then square it, and you get 25. Take half of it and then square it. That's the key to it. Okay? All right. From there, we're going to factor it. So this is going to factor into x what? Minus 5. Does everybody know how I got the minus 5? This number comes from where? Half of the b. And I will tell you, always take the sign of the middle number. If the sign is positive, then you'll take a positive down in your factor. If the sign is negative, then you'll take a negative down in your factor. Okay, just to help you remember. What's negative 24 plus 25? 1. Okay, then what? Take the square root to get rid of the square on both sides. What happens here? Oh, y'all don't do it with me. Cancel. And we get, Stack and Block did it with me. Here we go. What's the square root of 1? Plus or minus 1. And then we move the 5 over, and x equals 5 plus or minus 1. Chastity, would this be one that I would keep rolling with? Yes, because they're just whole numbers, so I can keep rolling with them. So 5 plus 1 is 6, and 5 minus 1 is 4. And didn't we say 2 seconds ago that the answers were 6 and 4? We knew that in the beginning because this one was factorable. But by the formula, it looks like that. Sky. I believe they can. So you can hear yourself. Go listen to yourself tonight. Ask that question. So, all right. So here's what I would like for you to do. I want you to go as far as you can with this problem. Go as far as you can to where you get stuck, okay? And then we'll answer our questions. All right, so any questions on I need to add a 4? Does everybody know where I get 4 from? Okay, so then I'm going to factor it into what and what? X plus 2 squared. Where do I get the 2 from? You could get it from 2 different places. You could half this, or you could take the square root of that. Do you understand that? You could half the middle number or take the square root of the end number. Either way, that'll get you your number right here, okay, which is 16. Anybody want to tell me your final answer? 2 and negative 6. That's what I hear. How many got 2 and negative 6? Yay. Okay, good. So then I'm going to take the square root on both sides. Those will cancel, and I get x plus 2 equals what? Plus or minus 4, and then I move the 2 over, and I get negative 2 plus or minus 4. I'm going to keep rolling with it. So negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. Any questions? You just forget. All right. How many are good? All right. Let's try some more. How many are starting to like this a lot? Like better than the formula? Do I have any that are still formula takers? And that's all right. That's all right. In the end, I don't care. You've got to be able to do it one of the two ways. So I always look at my trinomial first to see if it is factorable. I look at it. I might put it in my calculator just to see, does it cross twice? Does it cross once or does it not cross at all? Just to kind of see where I need to go. And when I do put this in, I can tell you right now, it's not going to cross. So immediately that means I need to turn to either the formula or completing the square, because you're going to have to get your eyes. So what's the magic number that needs to go? 1. The magic number is 1. So I know I need,
what number needs to go?
Yeah, the 2 needs to go. I agree. Okay? But do you understand what I'm saying? Like, I always look, like, it might be that I already have a perfect square trinomial that I don't need to move it over. So I don't just get in the habit of moving it over and then figuring it out. Kind of look and see what number needs to go there first. And if it's already there, then I'm good. And if it's not there, then I need to move it over. So I know this needs to be a 1. Any questions on why it needs to be a 1?
So, like, is the last part always going to be a positive?
Yes, the last part will always be a positive. Okay, please listen. This is a good question. The last part doesn't always, she's saying, is this guy right here. Let's just say the middle number's negative. If you take half of it, you get a negative, right? But when you square it, what do you get? You get a positive at the end. And if the middle guy's positive, if you take half of it, you have a positive. And if you square it, you have a positive. So I agree, you're always going to be adding it to the end. Okay, it's never going to be a negative. So then you have x plus 1 squared. And that's going to give you negative 1. When I take the square root on both sides, what's the square root of negative 1 by definition?
Net plus or minus I.
Plus or minus I. Okay, and then when you move this guy over, I would put him right in front just so you're in proper form. Negative 1 plus or minus I. And I would leave it, why would I leave this one, Chastity? Right, because it has an I in it. And you can't add a negative 1 and an I together. So I would just leave it. Okay? All right, so let's see what we get. First of all, what's the magic number going to be? Before I even move that 25 over, I just want to check to see, maybe I already have a perfect square trinomial. What's the magic number going to need to be? 9. Does everybody understand? Half of negative 6 is negative 3, and when you square negative 3, you get 9. So you're going to need a 9 right here. So I'm going to throw him away. So minus 6x plus something equals negative 25 plus something. And that something's going to need to be a 9. Does that help a little bit? So from there, this will be x minus 3 squared. And that's going to be a negative 16. So far, so good. Then I'm going to take the square root on both sides. These cancel. And I'm left with x minus 3 equals plus or minus 4i. And then I just simply move the 3 over, and you get 3 plus or minus 4i. And I would leave this one y, because 1 has an I with it. 1's a whole number. It's called a complex number. You just leave it in a plus bi form. Okay? All right, so I'm going to leave you with this one for lunch. I'm going to tell you really quickly what's different about it. It has a coefficient. And I'm going to tell you right now, in order to complete the square, the coefficient has to be uno. So how do I get rid of that 2? I'm going to divide everything by 2. And so this is going to become x squared minus 7 halves x plus 5 halves equals 0. You'd have to divide that by 2 too, but 0 divided by 2 is 0. Okay, so before we went to lunch, we discussed that when solving using completing the square, first thing, it's got to be set equal to 0. Second thing, the coefficient of the x squared term, the leading coefficient, has to be equal to 1. So when you have a coefficient in front, the very first thing that needs to happen is you need to divide by 2. And when we did that, you get x squared minus 7 halves x plus 5 halves is equal to 0. Okay? And then if we set it up to do our completing the square, I do want to tell you, I'm going to take this one slow, but I want you to understand it is completely doable, even though it's scary and has fractions every which way. It's completely doable, especially since you have a handy-dandy little device that helps you compute all your fractions, right? Helps you add fractions and subtract fractions. What do we call that thing? Oh, a calculator. Yes, okay. So x squared minus 7 over 2x plus something is equal to negative 5 halves plus something. So far, so good. Now, what's the key to finding the magic number? All right, so in your calculators, everybody do this for me so I can show you that it's not that hard. I want you to take parentheses, 7 divided by 2, close parentheses. Make sure you put your fraction in parentheses. Okay, you can either or, it don't matter, because when you square the negative, what will you get? A positive. So either way, you're going to get a positive at the end. So take 7 over 2, divide it in half, divide it by 2, get an answer. Everybody got an answer? And then square it. And then I want you to go math, enter, and I want a fraction. 49 over 16. Everybody's like, oh my gosh. Well, it's not that big deal. I promise you it's not. So we're going to add 49 over 16 on both sides. From there, what do? We factor it. So this will be x minus, now what's the key to getting the number that goes there? You can get it from two different places. You can half the middle guy, or do what? Or take the square root. I almost like to take the square root of this. What's the square root of 49? 7. And what's the square root of 16? 4. If you take half of that and math enter it, you'll get 7 over 4 too. Does everybody understand that? Make sure you're trying it out. Make sure you're getting it. If you have any questions, let me know. All right, in your calculators, I want you to go ahead and add these. What's negative 5 over 2 plus 49 over 16? Nine over 16. Okay, we're okay. What do you do from here? Take the square root of both sides. So the square and the square root cancel. In my next life, I'm going to be a singer, just so you know. All right, what's the square root of 9 over 16? Plus or minus 3 over 4. And you can put that in your calculator if you need to, or I just look at it and I say, okay, square root of 9 is 3, square root of 16 is 4. So far, so good. Then I just finished solving it. So I'm going to move the negative 7 over 4 to the other side, and x is equal to 7 over 4 plus or minus 3 over 4. Now the question is this one, can I add fractions? Yeah, you can add them. So let's roll. And it's not even as difficult as you think. Some people just look at fractions. Anybody ever just look at fractions and just be like, I can't do this? Because you get scared of them. But this already has common denominators. 7 over 4 plus 3 over 4 would be equal to what? 10 over 4, which reduces to 5 over 2. And again, you can put it in your calculator if you're not that comfortable with it. Then 7 over 4 minus 3 over 4 would be 4 over 4, which is equal to 1. So even though it looks really scary and it has fractions every which way, it's still, to me, using the same concept of what we've been doing, and you can use your calculator to help you. So it is doable, I believe. So I want you to try this one on your own. what would be the very, very, very first step? Divide everything by 3. You got to have a coefficient of 1. All right, so what's our magic number? 25 over 9. That's half the battle right there. How many were able to come up with 25 over 9? Good. Very nice. 25 over 9. Okay, so from here we're going to factor it. So this will factor into x plus, and the key to getting this guy, you can take half of him, or you can just take the square root of the last number, which would be what? 5 over 3. And when you add 8/3 plus 25 over 9, you get, say it again? 49 over 9. Any questions so far? Does everybody understand how I get 49 over 9? And you just make sure you put parentheses around these when you add them. And then you math enter, and get your fraction. So then I take the square root on either side. So this will be x plus 5/3 is equal to plus or minus, what's the square root of 49? 7 over 3. Okay? And then we're going to move this over, and x is going to be negative 5/3 plus or minus 7 over 3. Is this one that we keep going, or is this one that we leave? Keep going. You can add fractions together. So here we go. Negative 5 over 3 plus 7 over 3 would be 2 over 3. And negative 5 over 3 minus 7 over 3 would be negative 12 over 3, which is equal to negative 4. Would this one be good to do in the calculator? Are they real?
Well, yeah.
Yeah. Yeah, this one's fine to do in the calculator. This one probably would even, I think it will actually, factor. I think it's factorable. Okay? Can anyone tell me, just reviewing really quickly, what if the answer is 2/3 and negative 4, what the factors are? X plus 4. Now here, remember this one. Yeah, you got to work backwards. Remember? You got to undo it.
3x
Bingo. 3x minus 2. Remember, you set it equal to 0, right? And if you move the 2 over, you get 2, and then you divide by 3, you get 2/3. But the factor would be 3x minus 2. Don't forget that, okay? Don't forget that. So I'd say it would be factorable as well. This one would be, you would be able to do this one by all the methods, okay? All right, last one. Bless you. Do I need to divide by coefficient? No. So we can go directly into completing the square. I do caution you, always look at it first. What would my magic number need to be? 16. Okay, so that does mean that I need to get rid of this one right here. All right, when I factor this is going to be x plus 4 equals negative 6. When I take the square root on both sides, I get x plus 4 equals plus or minus I times the square root of 6. What if I had a square root of 8? You could break it down, right? If it can be broken down, you need to break it down. But if it can't, you just leave it, okay? And then we move this over, and x is negative 4 plus or minus I times the square root of 6. Is this one, Chastity, that we leave? Yes, why? Because it's an I and a radical. You can't add, they're not like terms, so just leave it, okay?